Hello students, today we are going to start the fifth part of chapter electricity. So today the first topic we are going to start is power voltage rating of electrical appliances. You might have seen that the various electric appliances, for example, electric fan, electric bulb, radio, refrigerator, ACs, they all have some voltage and electric power rating written on them in form of a label or on an engraved plate. For example, if a bulb has a label with 100 watt and 220 volt, it means that the bulb consumes the power at a rate of 100 watt. It means it will consume 100 joule in 1 second and it will work on 220 volt. The bulb will work on 220 volt. So this is what the meaning of the power and voltage rating. Okay, and this rating gives us an idea about at what rate the electrical energy is being consumed by the appliances. Okay, for example, we know that the electric energy consumed by a refrigerator is more compared to that of a bulb because the power rating of bulb is less compared to the refrigerator. So it gives an idea about the energy consumed. Here we can see an example that incandescent bulb is of 60 watt, whereas CFL is of 14 watt and LED is of 12 volt. Okay, so less would be the power rating, less energy it is going to consume. That is why nowadays we are mostly using LEDs instead of CFL bulbs. Okay, so if a bulb has 100 watt, it is consuming 100 joules per second. Similarly, if an electric appliance has 500 watt, it will consume 500 joule per second. So this is the meaning of the power rating of an electrical appliances. Now let's see what is the formula to find the electrical energy. Okay, we generally know about the formula of the power, that is P equals to W by T. Okay, we have also used this formula in the previous part. Okay, now the formula is being derived from the same this formula, that is P equals to W by T. Now according to law of conservation of energy, whatever work is done by electrical current, it is same as the electrical energy consumed. Okay, so it means the W, that is a work done, can be replaced by the energy consumed. So in this formula, that is P equals to W by T, if W is replaced by E, the formula becomes like this: P equals to E upon T, which can be again written as E equals to PT. So this is the final formula that is going to be used to calculate the electrical energy for various electrical appliances. Okay, now what we can conclude from this formula? It can be concluded that electrical energy consumed by any appliances depends on two things. What are they? The first one is power rating of appliance, and the second is the time for which the appliance is used. That is why we are always asked to use a low power appliances, or we always check appliances with of a good power rating. Okay, and we are generally advised to switch off the fans or lights when it is not needed. Why? To reduce the time for which the appliance is running. So finally we need to reduce the amount of electrical energy consumed by that appliances. Okay, so from this formula, these are the 2 points that can be concluded. Now let's move to the next topic. It is understanding the units. Okay, now let's see that what does this unit means. Okay, from this formula, that is E equals to P into T, we know that power is usually expressed in watts, whereas the time is expressed in hours. Okay, we also have smaller units like minute and second, but we are using electric energy in for more time. That is why an hour is used. Okay, so according to this two units, the unit for electrical energy becomes watt hour. So watt hour is the unit of electrical energy, which is written as WH. It is expressed as WH, capital W and small h. Okay, now what is 1 watt hour? Okay, 1 watt hour is the amount of energy consumed when an electrical appliance of 1 watt is used for 1 hour. If means if there is some device on an appliances whose power rating is 1 watt and it is being running or it is being used for 1 hour, then we will say that in 1 hour the energy that it has consumed is 1 watt hour. Okay, now again 1 watt hour is a smaller unit for energy because we are using uh, electrical appliances with higher power ratings, so we need some bigger units of power, and they are kilowatt, that is 10 raised to 3, which is equal to 10 raised to 3 watt. Here here is a figure of electric iron. Here you can see that the rating of power rating is given. Here we can see that it is 100 watt. It is 100 watt, means it is equals to 1 kilowatt. Okay, now the next unit is 1 megawatt, which is equal to 10 raised to 6 watt, and similarly 1 gigawatt, which is equal to 10 raised to 9 watt. Generally this, the higher units, that is megawatt and gigawatts, are used uh, to describe the amount of energy produced at power stations. Okay, because they are really high. Now let's see what is the practical unit. The practical unit of power is horsepower. Okay, earlier it was used to express the amount of power before this watt. Okay, so generally you might have heard that a car has this much brake horsepower, like that, and even the machines, the power of machines are expressed in horsepower, and the relation between this horsepower and watt is this, that is 1 horsepower is equals to 746 watt. Okay, so this was about the meaning of unit of electrical energy. Now let's move to the next topic, that is commercial unit of electrical energy. Okay, now commercial unit means the unit in which we get the electric bill, and or the unit for which we are paying the electric bill. Okay, so the commercial unit of electrical energy is kilowatt hour. It is kilowatt hour, or it is also known as unit, simply as unit. Okay, for example, you may be getting an electric bill, okay, in which it is mentioned that this much unit has been used for these 2 months. For example, here we can see that uh, that for the month of November, the amount of unit used is 132. It means 132 kilowatt hour energy has been used. Okay, and even in this meter we can see that it calculates the energy used in kilowatt hour. Okay, here we can see it is kWh, means it is calculating the amount of electrical energy that our house is consuming. Okay, now let's see what does this mean. 1 kilowatt hour is the amount of energy consumed when an electrical appliance of power rating 1 kilowatt is used for 1 hour. Okay, just now we saw a figure of an electric iron in which the power rating was 1 kilowatt, that is 1000 watt. If electric iron is being used for 1 hour, then we will say that the energy consumed by electric iron is 1 kilowatt hour, that is kWh. Okay, so it was about the commercial unit. Why it is kilowatt hour? Because the energy, whatever power rating appliances we are using, they are not, means they are having higher power ratings. Okay, so and even in industries the machines use lot of power, and that is why higher units of power is being used, that is kilowatt. So just keep this in mind, that commercial unit is kilowatt hour. Now let's move to the next topic. Yeah, now our topic is what is the relation between kilowatt hour, that is kWh, and joule. We know that electrical energy is also expressed in joules. So let's see the relation between them. Okay, we know that the commercial unit is kilowatt hour, and 1 kilowatt means it is around, it is equal to 1000 joule per second, because watt can be expressed as joule per second. Now let's see the relation. 1 kilowatt hour can be written as 1 kilowatt into 1 hour. Okay, that is P into T. Now kilowatt can be written as 1000 watt, and this 1 hour can be written as 3600 second, and this watt is replaced by joule per second, because power is equals to work done upon time. So joule per work done and second for time. So on calculate this second and this second gets cancelled. So the left out part, the left out unit is joule, and so the left out number is 36 lakh joule, which can be written as 3.6 into 10 raised to 6 joule. So it is a final relation that 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. So in numericals, if it is asked to convert a kilowatt hour into joule, then we directly have to multiply this 3.6 into 10 to 6 joule with the given number to convert it into joules. Yeah. Now, generally electrical energy, which is that is used in homes and industries. Okay, they are expressed in kilowatt hour because the amount of energy being used is too much. Okay, and the electrical energy used during a month, it is expressed in units. For example, just now we saw the figure of electric bill. Okay, it was mentioned that it is 132 units for the 2 months. Okay, so 1 unit means 1 kilowatt hour, means instead of writing 1 kilowatt hour, it is simply written as 1 unit, and this is a unit for which we are paying the electricity bill. Okay, means the amount is fixed. For example, in our area, that is in Gujarat, it is around something 6.5 rupees for 1 unit. So accordingly, we can calculate the total amount. If suppose the unit being used for 2 months is 200 watt, sorry, it is 200 unit, then we can directly multiply 200 by 6.5. So we will get the total amount of electric bill that we have to pay. Okay, so this was the relation between the kilowatt hour and joule. Now let's move to the next question. We will solve a question on the basis of the given formulas. Okay, the question is, an electric heater draws a current of 10 ampere, means current is provided from a 220 volt supply, means the voltage is provided. What is the cost of using the heater for 5 hours? Here time is given and it is for 30 days. Yeah, and even the cost of 1 unit is given, it is 2.50. It's quite cheap. Okay, now let's see. We will start with the formula of power, that is P equals to VI, because we have voltage and we have current. Okay, so value of voltage is 220 volt and value of current is 10 ampere. So finally we get power as 2200 watt. Now we need to find the electrical energy, and the formula is E equals to P into T. P into T. The we will put the value of this power, that is 2200, and time is 5 hours. So on calculating, we will get 11,000 watt, but it is only for 1 day. Okay, because it is being used for 5 hours per day, but we also have to calculate for 30 days. So we can simply multiply this overall values with 30. Okay, here see, here 11,000 is converted into kilowatt hour by dividing the given number by 1000. It has been converted into kilowatt hour. So by multiplying this 11 with 30, we will get 330 kilowatt hour. So this is the total amount of electrical energy being used for 1 month. Now to calculate the cost, simply we need to multiply 2.50 with 330. So the final answer is 8.25. So this is the final answer. There is a total electric bill that a person has to pay. Okay, now students, you have few questions to solve. Just go through it. Answers are given at the end of the question. And so here we are ending this part. Hope you understood all the topics. If yes, then please comment in the comment box. Okay, thank you.